This is to complement 7.4 example 10 using half angle identities to find exact values, and we're doing this for tangent. So the tangent of an angle divided by 2, the formula equals sine A over 1 plus cosine A. So as long as you know A and have it memorized, you can do this. So we're going to find the tangent of 75 degrees. Well, I can write 75 as 150 divided by 2. So I'm going to write tangent of 150 degrees divided by 2 because I know that 75 equals 150 divided by 2. And now I can apply the formula. So I can say, oh, this is sine of 150 degrees over 1 plus cosine of 150 degrees. So sine of 150 degrees, think you're in quadrant 2, so sine is positive. Reference angle is 30 degrees, so that's 1/2. So there's the sine of 150 degrees, 1/2. You've got to know your unit circle values. Denominator is 1 plus, now be careful, cosine, because you're in quadrant 2 for 150 degrees, not for the 75. The cosine of 150 degrees is negative square root of 3 over 2. So this becomes 1/2 divided by, well, common denominator here is 2, so it's going to be 2 plus a negative, or 2 minus square root of 3 all over 2. And when we invert and multiply, these 2's are going to divide out. The 1 is going to be on top, and the 2 minus square root of 3 is going to be on the bottom. We can't leave it like that. Again, we don't like radicals in the denominator. So I want to use my favorite, a plus b times a minus b equals a squared minus b squared. Difference between two squareds comes up a lot. So I want to do that to rationalize my denominator. Here's my a minus b, so I need to write an a plus b. And I need to do that times top and bottom. Again, we're multiplying in the numerator. So that means in the numerator we have 1 times 2 plus rad 3 is simply 2 plus square root of 3. In the bottom I have a squared, which is 4, minus b squared. Rad 3 squared is just 3, and 4 minus 3 is 1, so I'm left with 2 plus the square root of 3. Now that's the answer, and we're done, and that does equal the tangent of 75 degrees. But I wanted to show you something interesting. If you recall, earlier on in this section, we're using sum and difference formulas. And I could have used a sum and difference formula to solve for the tangent of 75 degrees, and sometimes the answer looks quite different, but if you plug it into the calculator, so if you put in 2 plus square root of 3, square root of 3 is approximately 1.732, so this would give you 3.732. So you know that these are, tangent of 75 degrees is going to give you 3.732. It's going to go on infinitum. Anyway, I digress. If I want to use the tangent of 75 degrees, which is what we're starting with, I could have used a sum and difference formula. I could have said, oh, that's tangent of 45 degrees plus 30. Well, in other words, when I use this formula, the sum and difference formula, I should get the same answer. And may not look exactly the same. Sometimes it does, though. Or at the very least get the same decimal equivalent if I'm doing things correctly. Well, the formula here is, if you recall, it's tan A times tan B. So tan of 45 degrees times the tan of 30 degrees over 1 minus, these signs are different here, tan A, or tan 45 degrees. Oh, sorry, this is plus. Wow. Okay, let's start all over again. Tan of A plus B is tan A plus tan B over 1 minus tan A times tan B. Make sure you get the formula correct. I almost made a Decker goofy mistake. You'd never do that, right? What is the tan of 45 degrees? Well, that's 1. The tan of 30 degrees is 1 over rad 3, or you could say it's rad 3 over 3, however you want to play that out. Really doesn't matter. Do it either way. I'm going to put the exact unrationalized. You could rationalize the answer. Sometimes it's handier to rationalize it. Sometimes it's not. I always forget when it is and when isn't. That's in the numerator. In the denominator, we have 1 minus 1 times 1 over square root of 3. Well, what are we going to do in the top here? In the top here, it probably would have been good to rationalize. This becomes rad 3 over 3. This becomes 3 over 3. So you wind up getting, well, I'm going to de-rationalize it. I'm going to make 1, sorry, I have different ways of doing it. 1 is square root of 3 over square root of 3. I'm giving a common denominator there of rad 3. Rad 3 plus 1 all over rad 3. You can do it either way. I'm sorry that hopefully that didn't confuse you. So 1 comes disguised as rad 3 over 3, rad 3 plus 1 all over rad 3. That's in the numerator. Over here we have 1 minus 1 over rad 3, which means this is going to be, 1 is going to come disguised as rad 3 over rad 3. They have the same denominator, so this is 1 minus, and 1 is rad 3. So rad 3 minus 1 over rad 3. Either way you do it, when I invert and multiply, this is going to be on the top and the rad 3's are going to divide out. You're going to be left with this in the numerator, square root of 3 plus 1, and this in the denominator, square root of 3 minus 1. And again, we don't like radicals in the denominator, so we're going to multiply top and bottom by the conjugate of the denominator, not the numerator. So rad 3 minus 1, there's a minus b. I want to multiply times a plus b. So in the denominator, I get a squared minus b squared, or 3 minus 1. So ultimately in the denominator, I'm going to get 2. In the numerator, I have rad 3 times rad 3, which is simply 3. I have 1 rad 3 plus another rad 3. In other words, I have 2 rad 3's. And I have 1 times 1. Again, I'm just foiling here. Curse is foiled again. And what are we going to get ultimately? We're going to have 3 plus 1, which is 4, plus 2 rad 3, all over 3 minus 1, which is 2. And hey, I could factor 2 out of the numerator and divide. 2 goes into 4 2 times, 2 goes into 2 1 time, and I'm left with 2 plus square root of 3. And by golly, that's the same answer that we had doing it the other way. Sometimes using different formulas, the answers will look differently, but if you put it in the calculator, you get the same decimal equivalent. In this case, you're going to get 3.371, blah, 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 and it rounds up to 2. Anyway, just showed you 2 different ways to find the same exact answer using the half-angle formula for tangent and then using the sum of 2 angles formula for tangent. They both give you the same 2 plus square root of 3 answer. Go figure.